if you're buying a brand new car, you expect a bigger engine, right? So why is the brand new RTX 5080 only about 15% faster natively than last generation's 4080? Welcome to the deep dive. Today's mission is, well, we are extracting the absolute truth from a comprehensive 2026 graphics card buying guide to help you navigate a pretty chaotic hardware market, because the silicon improvements have practically hit a wall. Okay, let's unpack this.
Yeah, it is a massive reality check for the industry. I mean, we are just so conditioned to expect massive generational leaps in pure, raw hardware processing.
Right, we always expect double the speed.
Exactly. But we've reached a physical plateau now. Simply making the silicon faster isn't yielding the returns it used to, so the heavy lifting is being handed over to deep learning algorithms.
Yeah.
The standout example in our sources is NVIDIA's DLSS 4.5, specifically their 6x dynamic multi-frame generation.
Okay, wait, so instead of physically rendering every single frame, this software generates like 5 AI interpolated frames for every one natively rendered frame.
Yeah, 5 for 1.
That's wild. It's like traditional 2D animation, you know? The native hardware is the lead animator drawing the keyframes, say the start and end of a punch, and the AI software is the junior animator rapidly filling in all the in-between frames.
That is a perfect analogy, and what's fascinating here is how that software pivot completely debunks some of the most aggressive marketing out there right now.
Wait, let me guess. If the junior animator, the AI, is generating those 5 extra frames inside the GPU itself, then that data isn't even crossing the motherboard bus, right?
The nail on the head.
So all that marketing pushing you to buy a new PCIe 5.0 motherboard is basically useless.
Pretty much. Because the frames never travel across your motherboard, the data pipe just doesn't need to be upgraded. The empirical data actually shows that running a flagship 2026 GPU on a legacy PCIe 3.0 slot only drops your real-world gaming performance by an unnoticeable 1% to 4%.
Just 1 to 4%? What?
Yeah, because it's only carrying the baseline data, not the generated frames.
So if you're listening to this and mapping out a new PC build, literally cross a new motherboard off your list right now. Keep your old one and put that money elsewhere.
Absolutely. But there's a catch with this new era of AI-generated frames. It's not the only thing eating up your card's resources.
Right, because gamers are increasingly running local AI assistants and modding tools in the background while they play.
Right, which means it's no longer just about core processor speed anymore. VRAM, your video memory capacity, is now king. Without enough VRAM, your local AI runs out of room on the card and spills over into your system's slower, regular RAM.
Oh, and that's when your smooth experience hits a brick wall of lag.
Precisely. You need a massive memory buffer to hold these neural networks locally. And this raises an important question about market disruption.
Intel, right. I saw this in the guide.
Yes, Intel. While everyone was looking at NVIDIA and AMD, Intel recognized this exact VRAM bottleneck for AI developers and initiated a massive sneak attack.
Right. They launched the workstation Arc Pro B70, offering an astonishing 32 gigabytes of VRAM for just $949.
Yeah, 32 gigs.
32 gigabytes for under $1,000? That's insane. They're aggressively capturing that developer market who just needs the memory space, rather than the absolute fastest gaming chip.
It's incredibly smart positioning because, I mean, when the entire industry suddenly relies on ultra-fast memory, what happens when it runs out? You get a supply chain war.
Oh, man. Case in point, NVIDIA decided to use bleeding-edge GDDR7 memory for the RTX 5080.
Yeah, which sounds great on paper.
It caused a massive global shortage. The card was supposed to have a $999 MSRP, but the memory shortage inflated its street price to $1,500 or more.
Exactly. It completely backfired for consumers.
Now, here's where it gets really interesting. I have to push back on AMD's strategy here. If AI generation is the whole future and AI requires massive ultra-fast memory bandwidth, isn't AMD shooting themselves in the foot by using older GDDR6 memory?
Well, I can see why you think so.
Because, I mean, won't that bottleneck the very AI features we just said were crucial?
You'd think so, yeah. But if we connect this to the bigger picture, the math actually works out in their favor.
Really? How so?
By using mature, widely available GDDR6 memory, AMD completely bypassed the shortage. Their new RX 9070 XT is currently the value king.
Oh, because you can actually buy it for its $599 MSRP.
Exactly. It gives you 16 gigabytes of VRAM and matches competitors in real-world performance entirely without the price gouging.
Wow. So what does this all mean? For you, the listener, it means ignoring the flashy box specs, basically. Prioritize VRAM capacity above all else to future-proof your system, lean into software maturity, and please refuse to pay those inflated street prices.
Couldn't agree more. You have to evaluate the hardware based on how it actually functions in the current ecosystem, not just what the theoretical maximums are on a spec sheet.
It really is a whole new landscape. And, it leaves me thinking, if silicon speed has truly hit a physical wall and local AI models just keep ballooning in size, will future graphics cards eventually stop being processors entirely? Are we heading toward a world where GPUs are just massive, expensive memory banks with a tiny little logic chip attached to the side, something to mull over next time you look at upgrading?